Alright, now we're going to do a typical question in vectors where we have to express these following vectors in terms of vectors u and v, given vectors u and v, and then after that write down two facts about the vectors AC and AR. Right, so firstly actually, even before we attempt this, we'll take a look at the information they're given us and the building blocks and the vector blocks they're given us, so-called, and see how we can fill up any gaps that we have. Okay, so for example, if they say dq, vector d to q, and pb are exactly the same, that means they have the same direction and same magnitude. dq is already known as v, as a vector v, so that means that pb is also vector v. We'll just fill in the blanks. Let's continue. And also on top of that, pb is 1/3 of ab, so this is 1/3 of the whole thing. So meaning if this is 1 unit, this whole ab is 3 units. In other words, a to b is, yes, 2 units of the vector v. Okay, what else? qr is half of qp. qr is half of qp. So this is like 1 unit and this is like 1 unit. Okay, in terms of magnitude. But we're not going to fill in anything in terms of u and v yet. Alright, so now let's answer the question. A to p. A to p. Oh, actually you've already filled that in. Based on what we had, it's actually 2 times of the vector v. Next, A to C. AC. Vector AC. I start at A and I end up at C. Well, that's pretty simple, right? You see, with the things that I've already filled in, I go from A to B first, and then I go from B to C. So A to B first, then I go from B to C, with which AB I already known to be 3 times of the vector V, and now I add the vector BC. As you can see, this is a parallelogram, so magnitude-wise, length-wise is the same as AD, and direction-wise is the same as well. They are parallel, so it's the vector U. So I'll just fill it in here as well. This is vector U as well, because it's a parallelogram, right? So that's it. That's the answer for part 2. Part 3, Q to P. Q to P. Q to P. Q is, as you can see, we're going to take a route in which we have a lot of the known vectors U and V, and then we're going to add it all up. So Q to P actually goes from Q to D, and then I go from D to A, and then I go from A to P. Okay, it's like taking the shortcut and I split it up into the so-called long cut. Okay, here, here, here. So when I go from Q to D, actually it's negative V, and then when I go from D to A, it's negative U, and then when I finally go from A to P, it's actually adding 2V. So I sum this up, and I will get actually V minus U. Okay, next, A to R. A to R. Now there's a few ways to do this. I will rely on QP. QP. And since this is 1 unit and this is, or rather R is the midpoint, A to R can be subscribed by this vector over here. In other words, A to D first, and then I add D to Q, and then I add Q to R. Okay, AD I already know to be vector U, DQ vector V, and now QR. QR is half of QP, right? So QP we already know to be V minus U, so half of QP. In other words, half of V minus U. And with that, I'll sum everything up, and I'm going to get 3 over 2V plus half of U. There you have it, answering the first 4 parts, expressing the 4 vectors in terms of U and V. Now, AC and AR. What facts can we write about them? Well, first of all, AC is equals to 3V plus U in terms of this vectors V and U. And AR is 3 over 2v plus half of u. Now, I'm going to purposely write it in this manner. AR actually is equals to 3 over 2v plus half u. You actually have to see that actually there is some common factor between them. Okay, usually the case when they ask you to write down two facts, they are either parallel or they are collinear. So I'm going to take out a common factor from both these numbers in front of the vectors v and u, and what I'm going to get behind is 3v plus u. And you notice 3v plus u is exactly AC. So in other words, I can replace this with AC and write it as half times of AC. Okay, so in other words, AR is some scalar multiple of AC. Therefore, from here, because they share the same point, the first thing we're going to say is that AR, the points A, R, and C are collinear. They lie on the same straight line, A, R, and C, because they are parallel and they all lie on the same straight line. Second thing, so that's direction-wise. That's what we always say, direction. They're collinear. Next, magnitude-wise, the length of AR and the length of AC. So clearly you can see that because AR is half of AC, so therefore the length of AR is half of AC. And these are the two facts about AC and AR.